Okay, welcome to those people who are not here. It doesn't look like too many. Well done, you're all here. Keen to get back, tired of the school of mommy and daddy. Okay, so for those who are not here, we're working through last year's final paper. Let's go to question 2, and can I ask you to solve problem 2.1? Use a vector scale diagram and represent all the displacements of the pirate. Use a scale of 1 millimeter is 1 meter. 1 millimeter is 1 meter. So let's draw us a map. 1 millimeter equals 1 meter. Okay, what is his first direction? So here's the palm tree. And the pirate goes how far, how far? He goes, from the palm tree, he goes 60 meters north. So which direction are we going to draw the arrow? Straight up. Okay, with the base of the arrow there, 60 moles. Right, you've got a ruler, and you're going to measure 60 moles up. Easy enough? Okay, once you do the rest, then go 40 meters east. Which direction is east? To your right. So now you go 40 meters. So this is 60, this is 40. And you see how we have the head to tail, head to tail. That's how we add vectors, head to tail. You're frowning. Is that easy enough? Okay, so can I just ask if you wouldn't mind keeping your mask? So my mask has never fallen down. That's because it's got a milk bottle inside it. So hooray for plastic milk bottles. Okay, can I ask you to just complete it and then tell us where you end up? So have you maybe not got a ruler? Got no ruler? Okay, then he goes 20 meters north. Which direction am I going to go again? Upwards by how far?
20.
Up 20. And then he goes 50 south. So from here, I go 50 south. And then I go 20 west. And what's the question? Here you dig and you find the buried gold. Use a vector diagram to represent all of this. What distance did the pirate cover? Distance did the pirate cover from start to finish. Now is distance a vector or scalar?
Vector.
Didn't we say distance is a magnitude only? And displacement is a vector. So distance is a scalar. So what are we going to say? 2.2. What distance did he travel? Distance is a scalar. So what do? We just add 60 and 40 is 100, plus 20, 120, plus 50, 170, 80, 90. He's travelled a total distance of 190 meters. Yes?
So, is displacement like the direction and how far is the...
Exactly. Okay, so how do we work out the displacement? We go 60 plus 40 plus 20 plus 50. You see, we don't care about the direction. Plus 20 equals 170, 80, 90, 190 meters. No direction. Okay, that was a nice 1 mark. Geez, you've got to work with your marks. This was my question. If if he walked the distance from start to finish in 10 minutes, what was his average speed? Okay, 2.3. Now speed, if I go on my motorbike and I go the speed limit, which is 60 kilometers per hour, does it have a direction? Is my speed on a motorbike a vector or a scalar? So speed is a scalar. So now we encounter another scalar, well, speed, and speed is like kilometers per hour, distance over time. Okay? Distance over time. Now guys, it's important in science, you just use the correct unit. So what is distance normally in science measured in? Meters. Not kilometers, but I know a dimension. But if we were doing it for school, everything's in meters normally and seconds. Okay, so meters per second. So if we did that all in 10 minutes, let's work out his meters per second, his speed. Okay, what is his average speed? Okay, speed equals distance upon time. What distance did he go? 190 meters over 10 minutes. But minutes is not seconds, so how will I convert minutes to seconds? Multiplied by 60. So I say 190 meters divided by 10 times 60, which is 600. 190 divided by 600. And anyone got a calculator? What's his speed? I can see it's like point something of a second. Point something of a meter per second.
0.32.
0.32 meters per second. Okay. Or meters times second to the minus 1 is another way of saying per. Who's lost? Anyone unhappy so far? So you've now met a second scalar, which is speed. Distance and speed. As the crow flies from start to finish, what was the magnitude of the resultant displacement?
130.
Woo. Okay, now we're talking vectors again. So I need to rub the board out. So please make sure you've got this down before I do. Okay, please just get that down. Don't not get it down. I can check, but I need to rub the left. Anyone unhappy with me rubbing the left off? This top one?
Yes.
Okay, just I'll read it to you. Vectors are quantities that, got that?
Yes, sir.
Have magnitude and direction. Got that? E.g. displacement, which an example would be 10 meters due north. Got that? The opposite is a scalar which has magnitude only. E.g. distance, e.g. 10 meters. Has everybody got this half down?
Yes.
Okay, because I need to rub it out. I've got that board, I'm going to paint it with blackboard paint or green board paint so that I can put it somewhere else and have a second blackboard because I've just run out of space. Okay. Oh dear, this was somebody's nice crew t-shirt at one stage. But it makes a lovely duster. When in need. Okay. As the crow flies, from start to finish, what was the magnitude of the resultant displacement? No, let me explain first of all what the resultant is. Okay. And I need a different color. If you go, and here is the start, and this is the end, that blue point there, your displacement is the arrow from the start to the finish. Or resultant. So this is a new term to you. If you add all the vectors head to tail, you get the resultant. So let's give a definition of what a resultant is. Adding all vectors head to tail gives the resultant vector starting at the start and ending at the finish. Do I need to write that? Yes. We can't be obvious enough. Okay. Starting at the start ending at the finish. Okay, so now you've got a new word, resultant. Okay, now you're scientists, you're geniuses. Suppose you haven't got your ruler here. Can you think of a way I can work out the resultant without a ruler, but maybe with a calculator? Don't we have some quantities left and some quantities right? And some up and some down? So can't we add all things up are positive, all things down are negative, all things left, let's call it negative, and all things right positive, and then just add them? Shall we do that?
Yes, sir.
Okay. So, what I'm going to do is I'm going to say let all things in the same direction cancel each other out. Okay, so I'm going to say let north be positive. So let's add all the north vectors. So how much positive do we have to start off with? 1. Plus 60. Okay, so we have plus 60. Ignore that. Plus 20. Now, if north is positive, south must be negative. Minus 50. Okay. Minus 50 gives us 67. 80 minus 50 is plus 30. So I know that my finish is 30 above where I started. I know my finish is 30 above where I started. Okay, who wants to do the same with the left and right? So let's call right positive. Let right be positive. Okay, so what is it going to be? Plus 40 Ignore that up and down. Minus 20. Gives us plus 20. So we know that he finished, if right is positive, we know that he finished 20 to the right and 30 above, up. 30 to the, so we know, so what do we know? We know he ended 20 to the east of where he started. So we've got two measurements, plus 30 plus 20. You guys heard of Pythagoras?
Yes.
We're going to use Pythagoras and we're going to work out the hypotenuse. So we could say the square, hypotenuse squared equals, what do you call it? X squared, or the, and
opposite
I don't know what they call it these days in math, but anyway, we're going to use Pythagoras equals vertical squared plus horizontal squared. Okay, let's call it that. And our hypotenuse is otherwise known as our? The hypotenuse is our resultant, where H is our resultant. Okay, so he went 30, so vertically he went plus 30 squared, plus, and he went 20 left, onto the right squared. 30 squared is 3 3s and 900, plus 2 times 2 is 400, that comes to 1300, and therefore H is the square root of 1300. And what is that equal to? If we put our maths is correct. Who's got a calculator? Square root of 13,300? And that would be the magnitude of our resultant. Okay, we'll leave it if you haven't got a calculator, but I'm sure someone's got a calculator. No?
Is it all?
Oh well, you forced me to get my... I'm a science teacher, not a maths teacher, but let's do it. Okay, so it's 1, 1, 3, 0, 0, square root, square root of 1, 3, 0, 0, 36. Okay, so now we know that the total displacement was 36 meters. Who's lost?
So I don't understand the last part.
Okay.
3 and 3. So
Okay. Let's. Now, did you guys realize that all the vertical stuff just adds up to one thing? All the vertical vectors, vertical and down, add up to just 1 of 30. Do you know this? That's what we did here. And all the ones left and right add up to a total of 20. So what is our resultant? It's going to be the hypotenuse.
Oh.
So there's your 30, there's your 20. All up down ones added to 30. All the left rights added to 20. So if we say 30 squared and 20 squared will give us R squared. Okay. And that's what I did.
Does or stand for resultant?
Resultant square. Or hypotenuse. Any questions? Any questions? Happy? Lovely. I love it when everyone's happy. Okay, so for your 4 marks, what was the resultant displacement? 36 meters. Won't you write it in here? Now calculate the magnitude of the pirate's average velocity. Ooh. So what's the difference between speed and velocity? The one is a begins with an S, scalar, and the other is a vector. Okay, so let's go to 2.5, the magnitude of the pirate's average velocity. So, let's say velocity is a vector equivalent of speed. So where speed is a scalar, vector is velocity is a vector. Whereas speed is a scalar, velocity is a vector. Okay, so what are we going to use for the distance over time? What was the total displacement over time? So velocity equals displacement over time. What was his total displacement? Anyone? What was his displacement? 36. In other words, the resultant is his total distance that he moved. 36 over, what's the time? Still 10 minutes. Which is 10 times 60, which is over 600 seconds. Now I'm going to have to rub that off. So let's work it out. 36 divided by 600. 36 divided by 600 equals 0.06. Meters per second. Okay, I think I'm going to give you a problem. Now, if I gave you a problem like this in the final exam or in September, will you be able to do it? Let's practice it. Anise, please. Okay, let's give you the same problem, but with new measurements. And then you work it out like I've done. Okay, so here the pirate starts at the palm tree. Anyone, just call me north, south, east, west directions and magnitudes.
West.
West, okay. West, how much?
20.
20. Then he goes south, 40. Then he goes east. Let's give a nice difficult number. 78. Then he goes, what compass haven't we used? North. Let's do 44. Okay. Now you work out all that I've done now. Sorry, what was that? A 20? Okay, that's a 20. And this was a 40, a 78 and a 44. So you see how I can give you the exact problem as a different measurement. So let's do it. So the first thing you're going to do is draw it. 2.1. Draw it. That means the minus 1 means per. It means it's the same thing as meters per second. That equals that. Per means divided by. Meters divided by 6. So the minus 1 means divided by. You've never seen that before.
I think you know.
I'll write it down. I will definitely write it down. We don't want to leave anything unexplained. Okay, draw. Everybody should be drawing. You should have already drawn at least a couple of them. Start 20. Wait. Okay, go on to the next one. What distance did we cover, got it? anything at the bottom? Another question? I should see a drawing line. So you add in left and right, up and down, separate. Okay. So you square it above the final square.
It didn't give it time.
For what? For the result.
Just use 10 minutes.
So does a time stay 10 minutes?
Has somebody said? Well, sharp on it.
So does the time stay the same? 10 minutes.
The time stays the same. Oh, what's that? So for your distance, you just add them all. 20 plus 40 is 60 plus 78 plus 44. Very good. Now there was a 20 at the end of the first problem. Our problem's only got 4. That's very right. So the next one. Like it goes, add the left and right, up and down. And it's squared in, then I'm squaring the both of them. And the minutes is still 600. It's still in 10 minutes. That's not complicated before you go to walk. That's not make you run. But I want to see diagrams, I want to see that you get it.
Yeah, okay.
So there's your drawing. Great. And what you draw your result in the result. Write it as you would work up. So you say this way, and then that's what you do. But next time bring the calculator. So your drawing is right. Is that correct? We'll see in a moment.
Sir, do you?
Okay, but not drawn the scale. Okay.
Sir,
Thank you.
sir, could you figure out the start to finish? Do you have to say that let move be positive?
If you're doing it that way, then you should state that a certain direction is positive, yeah. Because you've got to add your one direction positive, your one direction negative. You could make any direction positive, but do state it. Otherwise, the examiner doesn't know how you got it. Guys, do not sit and chat. Thank you. If you've got a question, please ask me. Ladies at the back here, please do not chat. Do not chat. Do not chat in the front here. Thank you. Do it by yourself. And if you've got a question, ask. So, let's just check your drawing. So, first of all, 20 west. Twice as far, or 40 south. Then, nearly twice the 40 east. Draw to scale. Then, 44 north. So, to scale, it's something like that. So, then let's say so there's your scale, whether you would do it in the exam with a ruler. Then let's find the distance. So we just add them up. So we're going to say the distance is going to be 20 plus 40 plus 78 plus 44. Okay, well done. 182 meters. So there's your distance. Then we're going to calculate 2.3 speed is a scalar. Let's find the distance over the time. 182 over 10 minutes. 182 still over 600. .30. Did you get 0.30?
Yes.
Right. 0.30. Any questions? Then, if he walks that distance from start to finish, there was 2.3. As the crow flies from start to finish, what was the magnitude of the resultant displacement? Now look, if you drew it accurately, you could take a ruler and just measure it in millimeters, and it would give you the answer. So if I drew this accurately, I'd take my ruler and measure from there to there, and whatever it is in millimeters, it would be in meters. Then you don't have to do any calculation. You get that? But because we don't have an accurate ruler, let's do it the Pythagoras way. So, we'll go here to this part of the board again. So, let right be positive. I should have said east-west, but again, he chose right and positive. So, let's have a look. He started and went minus 20. Minus 20. Then he went to the right at some stage, or east, plus 78. So that was the only one in the left-right direction, or the east-west. So minus 20 plus 78 equals plus 58. And if it's a plus, it means east. Do put that east, guys. And then we know that he also went down. So, sorry, I should have done this one here. Let's just do this one here. So that should have been minus 20 plus 78 equals plus 58. And then what am I doing? Okay, let's do the east-west one here. Let's do the north-south one here. Okay, so he went minus 40. Everyone with me? Yeah. Then he went eventually plus 44. Equals plus 4. Okay. Then we're going to do our Pythagoras. Now, if it's a minus and you square it, it still becomes a positive. So it doesn't matter if your answer is a negative, because a negative times a negative is a positive. So it's, both numbers are positive. So this is going to be plus 4 squared plus 58 squared. So that's going to be 4 times 4 plus 58 times 58. I get 3380. And then I'm going to do the square root of the answer, gives me 58. So the final displacement is the square root of 3380, which is 58 meters. Got that, guys? Got that, guys? Cole, got that, guys? I'll check before you leave. Now, that was then define the term velocity, it's displacement over time. Then calculate the magnitude of the pirate's average velocity. So then we go, velocity is displacement over time. What was his displacement? 58 over 600. And that is 0.096. And the answer is meters seconds to the minus 1. So what we had, if we were to draw our vector like this, just the two summarized, this would be 58 to the east and 4 to the north. And your resultant would be, let's do it in a different color, this answer we got, which was 58. Oh, okay, it's about the same. Because this is so small that both that and that are the same length, 58. Probably with some rounding off difference. So look, you've got something in the bag for the September exam already. But let's not rest on our laurels. Now somebody asked, what does it mean to the minus 1? Let's not leave that unexplained. So, is everybody good with this? You've all got this? So, let's just mention that to the minus 1 simply means divided by. Okay, so let's say to the minus 1 superscript. So all of that is raised. It's a small number above. Means divided by. So it just simply means our meters are divided by our seconds. Meters per second, or per. Okay, so it's obvious. Let's leave nothing unexplained. Okay, question 3. Let's see if we can master a second question. A taxi is speeding at a speed of 55 meters per second. Are those the correct units? Meters and seconds?
No. I mean, yes.
Are meters the correct units? You already learned that today? Yes. Are seconds the correct units?
Yes.
So you don't have to do any conversion. When a traffic light 40 meters ahead changes to red, now 3.1, we introduce a new scale, 3.1. Acceleration is a scalar, a vector. Do you know the Americans always thought he was going at a huge rate of speed, or he was going at a huge rate of acceleration, or something like that?
No.
Okay, that's the way they talk. It's scientifically incorrect. What is acceleration?
Okay.
Acceleration, or A, is change of velocity divided by change of time. Let's write it in words. Have you guys somewhere in maths or some other subject seen the delta sign?
Yeah.
Which means change of. Okay, so let's say delta means change of. But what does change of mean? Change of means final minus initial. But we're scientists, we've got to be scientific. That's why if I'm being scientific in this pandemic, I open the windows, I open the door, I open the windows, I keep social distancing, I keep my mask up, I do the things that are scientific. If you're not scientific, you're going to not care about a mask, you don't care whether the room is full of coronavirus, it's maybe someone who's got a positive. We've got to be scientific. Americans are not very scientific. They've got all kinds of, they think in magical terms, and the chief person is Donald whatever
Trump.
his middle name,
Trump.
John Trump. If you want an example of a non-scientific thinker. Oh, we wish this away. Okay, so scientists don't act like things don't exist. But we also are very specific. It's not initial minus final. It's final minus initial. So let's give an example. Let's suppose a starting velocity, e.g. starting velocity is, let's just see if this problem's got one. What is this minibus's starting velocity? What's his starting velocity? And we call it VI, or V initial. Is, what's it? 35 meters per second. Right. Remember, we're now getting very specific. Right is a vector. We're talking about direction and magnitude. Okay. So the driver takes 1 second to react before he slams on the brakes. The taxi then stops within 2 seconds. Is the velocity and acceleration of the braking taxi in the same direction as it moves towards the traffic light? Okay, but let's now get what was the final velocity. So his starting velocity was 35. What's his final velocity? Is that a 3.45 or that's a 35? What was the taxi's final velocity? 0. Thank you. You're a genius, my son. Okay, so let's say VF or V final of taxi is 0 meters per second. We don't have to give a direction. 0 doesn't have a direction. There's a vector with no direction. Okay. Won't you guys work out the acceleration of the taxi if it took him 2 seconds? Won't you work out the acceleration of the taxi if it took him 2 seconds to stop, which they said? Look, he waited 1 minute and then he applied the brakes, and then the velocity changed from 35 to 0 in 2 seconds. So how are you going to do it? What are we going to put on top? A is change of velocity over change of time in 2 seconds. Okay, what is change of velocity? V final minus V initial. Happy with that, everybody? What was his V final? Over 2. Over change of time. Look, change of time is time final minus time initial. But we just know it took 2 seconds, so we don't know that it was 3:45 to 3:46. Or 3:45 to 3:47, sorry, it's 2 seconds. So we can just leave it like that. What was his final? 0. What is his initial? What is the taxi traffic?
35.
Minus 35 over 2. And so what was the acceleration in this problem? About 17 and a half. Equals minus 17,5. Meters seconds to the minus 2 is the unit for acceleration. The minus 2 means divided by time twice. It means this. Equals meters over time times time. That's what it means. divided by time twice. So, any speculations why there's a negative? So which direction was the taxi going? To the right. But which direction was his acceleration? Did he go faster to the right? Or slower to the right? So whichever direction the force is the direction of the acceleration. So the force was pulling him back. So if he accelerated to the right, his acceleration would have been positive. But if he slows down to the right, it's actually a negative acceleration. You can get a positive vector and negative vector. You can get a positive acceleration, get a negative acceleration. What it means is a negative acceleration means it's in the opposite direction to the movement. So the taxi is moving right, but the acceleration is left. Okay, let's have a look at the questions.
So, if it, say for instance it was divided by 3, would it be m dot s minus 3?
No. This. So the minus 3.
Read the top, so you see 17. At the bottom 17. Now you see more to the right, you see that minus 2, so...
The superscript, would it be a 3 if it was divided by 3?
No.
Now I'm confused.
This 2 has nothing to do with that 2.
Now I see 2 there.
Okay.
You're confusing me.
Okay. Acceleration is a difficult concept. It means change of velocity. Now, velocity's got its own meters over seconds. Meters over seconds. That's a velocity. But when it's acceleration, it's meters over seconds divided by seconds again. Or velocity over time. Let me just try and explain that. Velocity is meters divided by seconds. That is velocity. But that divided by time, again, there's 2 seconds below the m. So that means meters, seconds, to the minus, there's 2 of them below. There's 2 denominators in seconds. And that is why velocity is meters, 1 divided by second, second to the minus 1. This takes care of that second. But acceleration is that again divided by time. Which means there's a second below it. And then that means second to the minus 2. And then all you have to do for the rest of your life is remember acceleration is meters seconds to the minus 2. It is meters divided by time twice. Believe me, I still haven't quite coped with the concept of acceleration. It's a difficult concept. It's a difficult concept. I can mentally, okay, you take meters, you divide it by seconds, divided by seconds, but what does it really mean? It's difficult. But I can cope with I can superficially understand it. But you're going to struggle if you try and go deep into thinking, what is acceleration? It will take you a long time. Okay. Now, are the velocity and the acceleration of the braking taxi in the same direction? Is the velocity and acceleration of the braking taxi in the same direction?
No.
Its velocity was to the right, but its braking was to the left. Retarded it. Its force, the force of the brakes pulled it to the left. So the answer to 3.2 is no. Velocity is to the right, acceleration is to the left. Won't you write that down? So here we've got 3.2. Velocity or B initial is to the right, and it's 35 meters per second, or 35 meters seconds to the minus 1. A, acceleration, is negative minus 17,5, or to the left. Now let me give you the one you're going to use for months in matric. Months. Here's my pen. I throw it up. What's the initial direction?
North.
What's the up? But is it being pulled by gravity up or down?
Down.
So although things are moving up, it's slowing down going up. So the acceleration is to the down. Now watch this. What's the direction of movement?
Down.
Down. What's the acceleration? Down as well. So something can be moving up but be accelerating down, meaning getting slower. Or something can be moving downwards, I'm throwing it down, but it can get faster going down. So that is what we mean. And do you see, in this little short period of time, I've introduced you to how important direction is. How utterly important direction is. Not only magnitude, direction. You could be a great person going in the wrong direction. That's terrible. Or you could be a humble person like me, maybe going in the right direction slowly. Maybe that's good. Direction is important. To use a social example. Okay. Give a reason for the answer to 3.2. What is the reason? One quantity is positive and the other quantity is negative. So give a reason. Is the velocity and acceleration in the same direction? No. To the right is positive, to the left is negative. Let's write that down. 3.3. No. To the right is positive, to the left is negative. Now, calculate the distance the taxi travels during his reaction time of 1 second. You know, guys, you don't have to be a genius to do this, but I can promise you, it's just common sense. He's going 35 meters every second, per second. And his reaction time is 1 second. He's going 35 meters every second, and his reaction time is 1 second. How far did he travel? How far did he travel?
35 meters.
You're a genius. He traveled 35. He's going 35 every second. 1 second passed, they went 35. Does it make sense? If 2 seconds happened, how far would he go? 70. If 3 seconds, just add 35 each time.
Oh.
But if he's going 35 per second, he went 35 in that second. Okay, so calculate the distance the taxi travels during the reaction time, 35 meters. But look, that's 4 marks. No, you can't just give an answer. Okay, so here is the formula you've got to use. We're going to use this formula. Let me give it to you. Now you've always got it. Displacement times time, velocity times time equals displacement. Now let's prove it. What are the units of velocity?
M is minus 1.
Meters per second. Times, what's the unit for time?
Second.
Second. Equals
Meters.
The time cancels out top and bottom and leaves you with just meters. And then let's prove it. So we take, what's his velocity? 35 meters per second times 1 second equals 35 meters. And that gets you your 4 marks. Now you can do the most horrendously complicated thing. Okay, I'm going to give you another example. I travel 60 kilometers per hour and it takes me half an hour to get home to Simonstown. How far did I travel?
You have to change minutes
30
to
kilometers.
seconds and
30 kilometers.
Now I don't even care if you give me the answer in kilometers. You don't have to convert it. How are you going to work it?
30 kilometers.
You're going to say velocity times time equals displacement. And what is my velocity? 60 kilometers per hour times a half an hour. And the hours are going to cancel out and I'm going to get 30 kilometers. Or think about it logically. If I'm going 60 kilometers per hour and I go for an hour, how far do I go? 60 kilometers. So if I go for half an hour, I go 30 kilometers, half the distance. Will the taxi stop at the traffic light?
Yes.
If he travels 35 meters, will the taxi stop at the traffic light for 5 marks? So how far does he travel in that first second? He travels 35
meters.
So how far is he from the traffic light?
5 meters.
5 meters. Then he applies his brakes and his velocity then changes by, we worked out his acceleration was 17.5 meters per second. Was that right? Yeah. It doesn't sound like he's going to make it, but how are we going to work that out?
The 2 seconds that it took to stop the...
I can think of one way. How many seconds has he got to stop?
1.
So if he goes from 35 to 0 in 1 second, is that a bigger acceleration than that, 17? No. He would have to accelerate at 35 divided by 1, which would be, he'd have to decelerate at 35 meters per second to stop. Am I right? No, I thought he wrote shit.
So he's
Been a long day. Okay, let's, they give you what are called equations of motion. That's the easiest way that you're going to work this out. At that acceleration, how long will it take for him to stop? And I don't have time, I don't know what the time is now, but I don't have time to get into the equations of motion. But you're going to use the equations of motion, which I will next time. So I don't want to go into that, it's a big subject.